and hitting broadcast now. Have a good show.
Hello, everyone, and welcome to Virtual Planetarium, The Sky Tonight, which is part of our MOS at Home programming. My name is Janine, my pronouns are she and her, and I'll be your moderator today. That means that I'll be asking some of your questions and comments that you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. If you'd like to see captions during today's program, you can click on the closed caption button at the bottom of your screen and select Show Subtitles. And if you're joining us on Facebook or YouTube, hey, wonderful. So thank you so much for joining us. Unfortunately, I'm unable to see your comments at this time. Welcome to those of you who are joining us for the first time, and welcome back to those of you who are joining us again. Let's meet our guide who's going to tell us what's up in the sky.
Hi everybody, my name is Katie. My pronouns are she and her, and today I'm going to be guiding you through the nighttime sky. So I will share my screen. I'm using a program called Stellarium, which is free to download, and there's also a web version of it, so you can go to stellarium.org to find that if you're interested. We'll have the link for you at the end of the show. So I thought it would be fun today because we're in the middle of the fall and the start of spooky season to incorporate some deep sky objects, so things like nebulas or galaxies or just stars that kind of have a spooky name or something fun associated with it for Halloween. So I will sprinkle that throughout the show, and I will also show you some constellations and how to find these particular objects. So I thought we would start looking over in the eastern part of the sky, and this is viewing at around midnight, so it's a little bit late, but I will also show you something a little bit earlier in the night. in, maybe like 10 minutes from now or something like that. So, all right, go ahead and look at this part of the sky and let me know if there are any objects or constellations or anything like that that you recognize, and you can type it in the chat. Also, if you have any questions throughout the program, please feel free to type those in the chat. I'll try to pause every once in a while to see what questions have come in.
Doesn't look like we have anybody typing in the Q&A, but I think I can see maybe a couple cool things. Oh, Isora, who's 9, sees Orion, which is one of the ones that I was going to mention.
Yeah, it's probably the most prominent constellation that we can see in this part of the sky right now. Orion is really bright, and it's easy to find if you know what to look for. So if you can find those 3 stars that are right in a row, then you'll have found his belt. So if we look here, we've got 1, 2, 3 stars in the belt, and then you can find the rest of the constellation from there. So if we come up this way, we find 1 shoulder, this way is another one, and then 2 legs and a very teeny tiny head right up here as well. He is a hunter, so he's got like a bow and arrow kind of coming out this way. You can see this arc of stars, and also a sword or an arrow coming up this way. That part you have to use a little more of your imagination. But in this constellation, there is a nebula. There's actually many nebulas, including this kind of fuzzy patch here. This is the Orion Nebula, which is not the one we're going to talk about today, but it is really pretty, and it's a place where stars form. So that's kind of cool, and you can see that with the naked eye. So if you find Orion and his belt, you can look near it to find that fuzzy patch. But in general, nebulas are these giant clouds of gas and dust in space. They can be dozens of light years across. They're really, really big, and they all kind of do different things. So some of them are where stars form. Some of them occur because of stars dying. Some of them are just giant clumps of gas and dust that happen to reflect a lot of light or absorb a lot of light. So it's kind of an overarching term for gas and dust in space. So the first nebula that I want to show today, and I'm going to put on labels for deep sky objects. So these are things that would work best with a telescope or even a strong pair of binoculars as well. But some of them are bright enough, like the Orion Nebula, that you can actually see it with the naked eye. So the first one is down here, and you'll see that it is pretty close to the Orion constellation, so it's still considered a part of Orion, and that's this nebula here called the Witch Head Nebula. So I'm going to zoom in, and let's see if you can see the witch. So here's my trick. If you tilt your head to the right, just completely horizontal, and then follow my cursor. So we've got the eye right here, and this is the nose. So it's kind of a profile view of the witch. So she's got the eye, there's the nose, here's the upper lip and the mouth, the rest of the mouth, the lower lip, and the chin. So if you can see the witch, go ahead and type it into the chat that you found the witch, or if you'd like me to point it out again, I can do that as well. It is kind of a weird, globby looking nebula. So without direction, it can be hard to spot. So Janine, did anybody find the witch?
Yes, Isora found it, and so did Barbara. And Roxanne says they saw a dragon.
Ooh, a dragon. That's awesome. Yeah, a lot of the different nebulas have multiple names a lot of the times, especially if you look throughout different cultures, different constellations, and different objects like this, like nebulas or galaxies. They will have different names because people from all over the world were observing, and so naturally different people see different things sometimes. So I love the dragon. Dragons are very popular in space too. There's a lot of constellations and other objects that are named after dragons. Over here, actually, I'm not sure what this is, but it's called the Cosmic Bat Nebula. So I say let's just zoom in and see what that looks like. I thought that the witch also kind of looked like a bat, but here's another cool nebula, lots of really bright stars in the foreground. So going back to the Witch Head Nebula, this particular type of nebula is called a reflection nebula, meaning that it just reflects a lot of light. And it reflects mostly blue light because of the particular kind of dust and gas that this nebula is made of. And the reason there's so much light that it's reflecting, or the source of all of the light that it's reflecting, is actually coming from the star Rigel. So this star right here is the foot of Orion. It's a very large and bright star. It's a very hot star as well, very energetic. So it emits a lot of radiation. And since it's really nearby to this nebula, and when I say nearby, I mean in terms of space distances, it, is still probably many, many light years away. But it is reflecting the light coming from this massive star in Orion. So it's kind of cool. Another reflection nebula that's in this general region of the sky, also in Orion, is right over here. I know there's a lot of labels, so it's kind of hard to see. So if I zoom in, you'll see that it's called Casper, the Friendly Ghost Nebula. It's not the official name. So the official name is M78, based on the catalog that it's a part of, the Messier catalog. It's also part of another catalog, NGC. So those aren't as fun as the name Casper, the Friendly Ghost, but this is another reflection nebula. So it's reflecting a lot of light, and it's not necessarily just visible light or light that we can see with our eyes, but it's light across the entire electromagnetic spectrum. So even some wavelengths of light that we can't see, it might be reflecting as well. So when we use telescopes, we put special filters on telescopes to be able to observe things in other types of light. And so when astronomers were looking at this particular nebula, in infrared, they found a lot of star clusters that were most visible in the infrared. So we wouldn't be able to see them, but when we use telescopes, we can see that there are a lot of star clusters in this nebula. So that's kind of cool. And this nebula, the Casper, is just one of many nebulas in the overarching Orion molecular complex, which is basically a really massive cloud that is made up of kind of smaller regions that have kind of clumped together to form these individual nebulas. So the entire kind of neighborhood is called the molecular cloud or the molecular complex, and then the individual kind of clumps in that, that's where we get different kind of specific nebulas. All right, so it's just a couple in this part of the sky, but I do want to turn our attention to the north, and if we have time later on, we can come back to this part of the sky, because in the wintertime, these are really prominent winter constellations. So as we get later into the winter, they'll be visible much earlier in the night, and they'll be higher up in the sky. So there's just a lot going on here, lots of really bright stars and awesome constellations. So if we have time, we can head back there. But I will turn toward, or actually I should go this way, turn toward the north. And Janine, have any questions come in so far?
We do have a question, which is, how do the stars only come at night?
That's a good question. So when we think about the stars, we always think about it being nighttime because that's when we can see them. But during the day, the stars are still there. They don't just turn off during the day. It's just that we can't see them for a couple of reasons. So our sun, we orbit a star, and we're very close to this star compared to the other stars around us. So we are completely illuminated by it when we're facing the sun. So that's when we have daytime. And another reason, so the light from the sun essentially is so bright that it's kind of outshining all of the stars around it. And Earth has an atmosphere. So all of the air around us that we breathe, right, that is the atmosphere. And when light comes from the sun and hits our atmosphere, it scatters around. And that's why we have a blue sky, which is awesome. But the scattering blocks out the light from stars. So that's why we can't see any of those stars during the day. And we have to wait until nighttime because that's when we're not facing the sun. And then we can see stars at nighttime. So they're still there during the day. We just can't see them. It's a good question.
And I have another question from Prisha, who's 8, and I think we're looking at the right part of the sky. They're wondering, in which direction can we see the Draconid meteor shower?
Oh, yeah. So the Draconid meteor shower is going to originate from the constellation Draco, which is in the northern part of the sky. So really low on the horizon here, you can see the Big Dipper. And then if we connect these two end stars here and follow them straight in this direction, we can find the Little Dipper. So this is Ursa Major and Ursa Minor. Those are the official constellation names. And then kind of snaking around in between the two is a constellation called Draco the Dragon. And it's a little bit hard to see, but it kind of goes like this through there. So let me turn on the constellation lines. Click that star. So this is Draco the Dragon, and it snakes right in between them. So the meteor showers are named after the part of the sky that they tend to look like they're coming from. So if you're trying to look for that particular meteor shower, you're going to want to look in this part of the sky and wait and see if there are any meteors coming in. Usually the best time to view meteor showers is in the middle of the night, kind of close to the morning. So at 3 o'clock in the morning or 4 o'clock in the morning, that just tends to be the best time and the time that you'd probably see the most coming through. I'm not sure exactly how populated this particular meteor shower is. Some of them you really can't tell if there's a meteor shower because there aren't that many coming through. But if you're looking for that meteor shower, this is the place to find it. All right, so we're still looking north, and if we go up higher in the sky, we will come to a constellation called Cassiopeia. Let me turn some of these objects off so that you can actually see it. This constellation is pretty easy to find in the sky because it's made up of really bright stars that are in the shape of an M or a W or a 3, depending on the angle that you're looking at it. Right now, it appears to us more of like an M. So it's like a zigzag here. So we got 1, 2, 3, 4, 5 stars that make up this constellation. There we go. And this constellation goes by the name Cassiopeia, the Queen. And there is a nebula nearby, close to this middle star here, which is called Navi. There's another nebula called the Ghost Nebula, separate from Casper the Friendly Ghost. But let me turn those deep sky objects back on. So it's actually technically called Gamma Cassiopeiae. So let's zoom in here. It's very close to this star. So if we get close, you'll see that it is kind of spooky looking and ghostly. When I was looking at this earlier, I also thought that it kind of looked like two dolphins, like a dolphin here and a little one here and like a wave in the ocean. But that's not quite as spooky as the ghost is. And this particular nebula is another reflection nebula. So that's why you see lots of cool colors. And this star actually has a really big effect on this nebula. So I mentioned that a lot of the light from the Witch Head Nebula is reflected from the star Rigel. This is kind of a similar scenario, except this star right here, Navi, is what's called an erupting variable star, meaning that it changes in brightness and it also has eruptions of material on its surface. So kind of like the sun has coronal mass ejections, where it'll sometimes shoot out lots of plasma and radiation out into space. This is kind of like an extreme form of that. So this star loses a lot of material every so often. and it kind of forms this big disk of gas around the star. And so all of that radiation and material kind of strips away at parts of this nebula. So you'll see that there's kind of this big gap right in the middle there. And that is partially due to the radiation and the violent nature of this particular star right here, because it is a variable star. Our sun is not a variable star, but a lot of stars are, where they just kind of naturally change in brightness. They'll get bright and then they'll get dim again, and it's periodic. But this particular star isn't as predictable, so it can have these violent eruptions pretty much, whenever, and it's hard to kind of map out. And speaking of variable stars, there's another one that has kind of a spooky mythology related to it, and it's in a similar part of the sky. So if we're looking north, but very high up in the sky. And so if we turn to look kind of near that area, I believe this star is part of it. Yeah, so this star is called Myrfak, and it's part of Perseus the hero. And that's not the actual star that I want to talk about, but it will get us to the right area. So here's Perseus, the hero. And this is the star that I wanted to talk about, called Algol. Now, this star is nicknamed the demon star because of its place in mythology, and specifically Greek mythology. It represents Medusa, which is a gorgon, and that's where the demon kind of comes from. So Medusa it's specifically the head of Medusa. So the Medusa had, instead of hair, she had snakes for hair. And this is, again, according to mythology. And it was said that if you ever looked her in the eye or looked at any of the snakes or anything like that, you would turn to stone. So it was a very frightening figure in mythology. And so this star represents Medusa, specifically the head of Medusa. And this is another variable star. And astronomers think that it's possible that because this star changes in brightness over time, that ancient astronomers or just people that were observing the sky thought that there might have been some spooky thing going on there because it changes brightness. It also spins very quickly. So it has kind of like a bulge in the center of the star. In medieval times, in Europe and in Arabic astronomy, this star is considered one of the unluckiest stars in the sky. I think there's a list of 15 stars that are considered the most unlucky, and the demon star is one of them. All right. So Janine, have any other questions come in yet? Otherwise, I'll keep going.
Yeah, we do have a question, which is a pulsating star the same as a variable star?
Yeah, so I think variable star is kind of an overarching term for stars that just change brightness. So a pulsating star is a type of variable star. So some of the reasons that stars can change brightness are, well, one of them is because stars expand and contract. And so when they get bigger, they get brighter because they have more surface area, so more energy can get through. So that's one way that a star can brighten. Another way a star can brighten actually doesn't have anything to do with the star itself, but what's around the star. So if a giant cloud of gas and dust is orbiting a star, it might look like it changes brightness over time. And that is also considered a type of variable star. So a pulsing star might kind of be more of a expanding and contracting situation rather than just it looking like it changes brightness.
Yeah, I'll add to that. There's a kind of star that I studied when I was in college called a cataclysmic variable, which is it's two stars, and one of them is kind of stealing the mass from the other one in a disk, and it'll all fall down on it at one point, and that makes the star brighten. So it's brightening because there's more mass being added to it, but not because it's pulsing, which is interesting.
Yeah, super interesting.
And then we have one more question, which is, where do comets come from?
Yeah, so another great question. Comets originate from much closer by. So In our solar system, we've got 8 planets, the sun, and then we have the asteroid belt, and we have another group of objects past Neptune called the Kuiper belt, and that tends to be kind of our local solar system neighborhood. But if you keep going out farther, about a light year away from the sun, you'll find this really big group of objects that is still being affected by the sun's gravity. So these objects are still technically in orbit around the sun, even though they are a light year away, which is really far away. That's about 6 trillion miles for reference. So some of these objects, they're like these small icy bodies that sometimes will get knocked into the inner solar system. And as they get closer to the sun, they heat up and they change from ice to gas. They completely skip the liquid phase and they turn to gas. And so that's why comets grow like a really big long tail. But this region of the solar system is called the Oort cloud, and it's where most of the comets come from, astronomers believe. All right. Well, I thought that kind of as a final thing to talk about, or actually let me point out Jupiter and Saturn really quick, because there are some moons around Jupiter that are a little spooky. So let me back up time. Let's see, we'll go to about 10 o'clock. So if we're looking southwest, you can see 2 very bright objects. The brighter one of the 2 is Jupiter, and the one that's nearby, not quite as bright, is Saturn, but we're going to zoom into Jupiter really quick. And Jupiter has in total 79 moons, but in particular, it has 4 that are actually the largest of its moons. They're called the Galilean moons, and these places are really awesome all on their own. So we have Ganymede, which is the largest moon in the solar system. We have Callisto, Europa, and Io. And Io in particular is a really cool moon because its surface is completely covered in volcanoes. And unfortunately, I can't zoom in to show you detail, but it is the closest of the 4 to Jupiter. And so its surface kind of looks like a moldy cookie. It's like yellow with all these spots on it, and volcanoes everywhere. And they're all just kind of spewing out sulfuric acid. So that's kind of one of my favorite spooky places in the solar system. And then Callisto, which is another one of these Galilean moons, is one of the oldest places in the solar system. It doesn't have any geologic activity, so it doesn't have any volcanoes or like earthquakes. I guess you'd call them Callisto quakes if they were on Callisto, but it has nothing that's actually changing its surface. So its surface has been unchanged for the past 4.5 billion years. So it's really kind of almost like a dead, barren moon that has a ton of craters on its surface from all of the impacts throughout the past 4.5 billion years. So those are 2 other kind of spooky pit stops. But as a final thing, I wanted to take us to Halloween night so that we could look at the moon. So let's go up to October 31st. Oh, that's 19. There we go. And this time is fine. And so let's look for the moon. Here we go. So in the southeastern part of the sky, you'll be able to find the moon. And the reason I wanted to bring this up is because on Halloween night this year, it is a full moon. And that's obviously exciting for spooky purposes, but also a full moon happens on Halloween night about once every 19 years. And I've seen a lot of headlines and articles that are saying it's going to be a blue moon, which is true, but it's not going to be the color blue, although that would be pretty awesome. A blue moon just means that you have 2 full moons in 1 month. Now, the thing about a full moon on Halloween is that it will always be a blue moon because the lunar cycle takes just about over 29 days, but October is 31 days. So if there is ever a full moon on Halloween, it will always be the second full moon of the month. So the fact that it's a blue moon, I mean, that's cool. It's a full moon and a blue moon on Halloween, but it will always actually be a blue moon if there's a full moon on Halloween. So I just thought we would end there. So I don't know if there's any last minute questions, but other than that, I am finished with today's show. So thank you all.
Oh, thanks. We have one last question from Prisha, which is how many moons does Earth have?
Earth has one moon, and it's this one right here, the one that I just showed you. There have been times where astronomers or planetary scientists have found like a very small asteroid that has orbited the Earth, but they're so small that they wouldn't really be considered moons, especially because they don't tend to stay in orbit. They'll just kind of float off them, maybe more like pass by. So we've only got the one.
Yeah, I like her a lot. We'll keep her, I think.
I agree.
All right. Well, thank you, Katie, for telling us all about these cool, spooky things in the sky. I definitely wish I had some nice dark skies and a good telescope to see them, but I guess I'll have to search on Google for some good pictures. I'll let you say goodbye.
Thanks, everyone.
And I would also like to thank you all so much for joining us today, for asking all of your questions, for sharing your comments. We really enjoyed this opportunity to share space with you all. It's a really cool thing, and especially as the nights are getting longer, it's more fun to find good things to do in the night sky. If you'd like to see what other virtual programs we're offering, you can follow the museum on our social media channels, or you can check out mos.org/mos@home. If you enjoyed today's presentation and would like to support more programming like this, you can visit engage.mos.org/welcome to support MOS at Home. And thank you to everyone who has. Today's program, as Katie mentioned at the beginning, was produced using the free software Stellarium, which you can find at stellarium.org. That's on the purple text on the screen right now, so you can type that into your browser bar. And thank you all again for joining us, and we hope you'll do it again soon. Thank you.